Hello and welcome to this session about Data Lakehouse for modernization of your big data analytics in the cloud. And specifically, we are talking today about how you do this with the IBM Cloud. My name is Thorsten Steinbach. I'm a distinguished engineer at IBM, responsible for big data in our cloud. And I'm today accompanied by Jason. Jason, you want to introduce yourself briefly?
Yeah, hey everybody. My name is Jason Hughes. I'm a director of product management here at Dremio, running the developer advocacy function, amongst a couple other things.
Yeah, and we're talking about actually big data technology in cloud, and we have two parts today of this presentation. After an introduction of the general concepts of data lakes, lakehouses, and so on, the first part will be more me showing you what is available out of the box in IBM Cloud for you to build data lakes and lakehouse solutions as a managed service capability. And in the second part, we will show you how this is basically complemented and augmented perfectly with Dremio technology. And we will also show you how you can deploy and run it in IBM Cloud and combine it with the data lake that you have built with the built-in capabilities of IBM Cloud. Now, we have a couple of material slides today. We also prepared a demo. We have just some slight technical issues today with the screen sharing, as we just noticed. So what we just decided, I will basically let you know when I was actually planning to show something live. And then we will get a recorded video to you out that you can download here when you're accessing the resources of this presentation in the next days. Okay, so let me start by giving you just a bit of a context. Why are we here today? We are talking about this thing about the lakehouse, but this is just the latest stage of an evolution of big data systems and big data approaches to how you store and analyze big data. It started decades ago when the concept of a data warehouse has been invented, which is basically just a spin-off of relational databases. Special form factors, special optimization of how to run a relational database so it can scale out and store terabytes of data and make it available for analytics through a very defined relation interface, which is SQL. Then about 2 decades ago, so Hadoop came up, and it added a lot of more openness. So it's not just SQL only anymore, it's more interfaces that you can use and APIs to analyze this data, map, reduce, and all of that. Various engines with various interfaces that it merged in the Hadoop ecosystem. But also, it has been the rise of open data formats that you could store in the Hadoop data file system. And with the rise of cloud a couple of years ago, this has changed again because now you have disaggregated architectures, and now the data is stored in object storage, and compute is something that you provision on demand and very elastically. And now we are at the next inflection point with Data Lakehouse. Here, the thing it's a continuation of this cloud data lake architecture that we just talked about with disaggregated storage and so on. But it tries to pull in more of the qualities of service that you traditionally only have in a relational data warehouse, like data consistency for transactions, concurrent reads and writes. You always have a consistent view, more security control, more fine-grained access control, also performance and scale, especially for interactive performance. But it also adds one more thing, a new basically twist here, and this is real-time first. This is actually something because more and more data that data lakes are facing today actually is not somewhere already that you just need to copy it into the data lake. No, you have to acquire it as you basically go. It comes in real time. So with that, let's look at the more of an architectural perspective on this whole data lake landscape. And the whole purpose of a data lake and also of a lakehouse is to onboard data for analytics, especially big data, so large volumes of data. Where does this data come from? Well, it can already be somewhere stored in your so-called systems of record, and databases, SAP systems, and so on. And then it's just a matter of basically copying it over into your data lake. This could be something like a batch ETL that you have scheduled, or more fancy, maybe you have an ongoing replication with a so-called change data capture mechanism, where the data is more in real time, basically replicated into your data lake. But as I said before, more and more data nowadays is coming in real time. Generally speaking, this is all telemetry data, telemetry about the physical world, like IoT devices, connected cars, right? The sensor data, measuring what's going on in the world, continuously coming in. That's real-time data, telemetry data. Could also be telemetry about your IT, right? Logs, application logs, and error messages, and all of that, what's happening in your system, continuously being acquired. Could also be telemetry about humans, user behavior, click streams, all of that. Now, this is all data coming in, and it can, when it comes in, be very rough. So then it goes through multiple stages in your data lake, starting with exploration. If you don't understand it yet, understand the schema, the structure, semantics, then you prepare it to be more of a known schema that you understand, that you want to use further down the road. You enrich it maybe with some other master data. You optimize it, also very important, because the data needs to be laid out properly on disk. So you can do performed analytics, and then you can start analyzing it, for instance, with a batch reporting. But traditionally, you then also always had the point when you ask yourself, do I need to pull in a data warehouse here as well? Now, the data is already prepared to some stage, but I have some interactive query capability. I need maybe some transactional consistency here for my analytics going on, some guarantees. Data warehouse is exactly that, and that solves these kind of problems. And the approach of the lakehouse, or the claim of a lakehouse, is exactly that, to try to, you can stay in architecture and basically use also into more interactive analytics, more transactional analytics guarantees with this data. At the same time, also opening up the data lake for other types of analytics that are not just BI, SQL-style analytics, like AI and machine learning and so on. So this is just conceptually to introduce a little bit what we are talking about here. Now let's look what we have in IBM Cloud. And what we have built into IBM Cloud today is something that we call the IBM Cloud Data Engine. It's a service in the cloud, in our cloud. It's actually not something new, even though we announced it and launched it under that name just in May timeframe. It has a predecessing service that has been called IBM SQL Query. But we added a major new capability, and that's why we basically launched it as this data engine service here. And this is this built-in catalog service. So you have data processing. That's what we have done for the past years already. And now we augmented it with a full-scale table catalog service. With that, you have one service that allows you to ingest, store, prepare, and optimize your data. So basically, this is this onboarding of the processing steps. As well as to create this data into a table catalog with all the technical metadata needed, so that then it can be analyzed. So this built-in table catalog is fully compatible with the Hive Metastore, which makes it usable with a broad set of engines that you can use to connect to and use this metadata. Because it's provided as a service, we also have full security in terms of encryption of this data. It's also serverless in the sense you just pay for what you use, right? This has been true for the processing already when you run data processing, but also for the metadata, only for the metadata, that when you use it, you pay basic for it. Now, if we look at a little bit more detail of the capabilities that this sums up in this service called Data Engine, we basically have on one pillar is the whole data ingestion. The capability here is stream data landing. So you can basically go from the Kafka service that we have in our cloud, we call it the event stream service, and say, I would like to land all of the data coming in through topics for this topic in this service continuously into Parquet data on object storage. That's what the service does for you. Then you have a data transformation, because when you land the data, remember, this is pretty rough, especially if you trickle land. You have a lot of small files, so it's very important that you have post-processing for various reasons, for performance reasons, but also to prepare the data for more semantical consumption quality. You can also do all of that with the data engine service. It has this ETL, or we call it ELT capability. Then when you've done that, you can also analyze the data in there. We call it the batch analytics. Right? This service is not optimized for very interactive performance, but if you want to have background jobs that still scale out very well, but that are not geared towards sub-second response times, perfect, you can do this with this service here. And all of that is augmented with a table catalog service. So all of those things you can use with metadata that you're also managing in the service. But you can also, again, use this metadata outside of the processing capabilities of this service. So you can connect your own big data services, your own Spark, for instance, your own Spark cluster to use the metadata here. Now, this would have been a point when I would pivot to a demo. As explained in the beginning, we will send you that as a recorded video very short after, so you can consume that here in the replay resources. Where I'm going to show you how you do that. How does it look and feel? How you set up such a streaming job? How you do with some post-processing? How do you do the metadata creation, creating a data mart on this landed and prepared data? And I'm also going to show you how you can use this metadata outside of the data engine service itself with, for instance, your own Spark runtime. That's also part of what I'm going to show you. Okay, now to put this service a little bit into a bigger context of services in the IBM Cloud, it's actually just the top layer of a whole wedding cake of serverless processing services in IBM Cloud. So at the bottom, we have the Code Engine service. The Code Engine service is a serverless container service. So you bring your containerized workload, anything that you can containerize, you can run with Code Engine, and it gives you containers on demand of any size, of any configuration, any time, and also any number of those at the same time if you want to scale out, right? On top of that, we have the Analytics Engine service in the IBM Cloud. The Analytics Engine service is a Spark service. So when you have Spark workload, Spark application, or a set of Spark operations that you would like to run, you can use the Analytics Engine service, which uses it in turn itself, the Code Engine, to get its resources on demand. And it gives you very serverless experience, basically, for a Spark application anytime you want it, of any size, CPUs, number of executors, and so on. And on top of that, we have the Data Engine service, which already explains anything that the Data Engine does, anything you will also see in this demo video, is under the hood running in Spark. And the interface with Data Engine is SQL. Now in the demo, you will see that basically even the data ingestion is at the end a so-called SQL job that you can express and submit. Metadata operations are DDL operations. Everything is through SQL language that you can submit ad hoc. And all of that can be combined. Again, the important message is here also, you do not have to decide which level you're entering. You can combine it very easily. You can say, I have some simple data preparation and ingestion jobs that are basically just submitting the data engine to do that for me. And I have maybe some more custom data preparation that I want to do, some custom code that I need to run. Then maybe you want to do it with Analytics Engine as a Spark job. Or you say, I have some Python code, some Python libraries that I would like to employ to, for instance, analyze this data after it has been prepared. Well, then you can run those in Code Engine. Okay. We are now looking at basically a little bit of the big vision that we are actually implementing here with in the IBM Cloud. So me and my team were actually in the middle of this whole journey, and Data Engine is sort of at the center of it. But the big picture means basically we have data that can be at rest in object storage. right? That because you have already stored it there, somebody has landed it there, and we are going from there. And we have data in motion. But in Kafka, and we have this service called Event Streams in IBM Cloud, which is a fully managed Kafka service. Now, we treat both of those data sources equally, right? So it's all basically first-class citizen data, which means we can say we run queries on data at rest, which means it's a batch query, but we can also, or we will be able to run queries also on data in motion, which is a real-time query that continuously just produces a result to refresh maybe a dashboard in real time. So it's partially a visionary statement, and it's transparent here. So the dotted lines are those things that are not available yet, but we are still working on, what is basically in the cooking. Data engine is also the thing that basically connects those two worlds. Like the stream data landing feature that I mentioned to you, where we're continuously landing things. This is exactly one of those things where we are taking data from in motion automatically as a service into data at rest, from where you can further prepare it and so on. We are also basically pulling those things together through some common metadata layer. So we have this Hive Metastore service, Hive Metastore compatible service that I mentioned already as part of the data engine available now. But we're also already working on the integration with the metadata for Kafka, the Kafka schema registry. At the same time, we are also working to embrace metadata from the data itself. There is a new set of file standards evolving around the Lakehouse initiative, or the Lakehouse trend, like Iceberg, Delta Lake, and Hudi. So those are heavily infused with metadata, new file formats that enable actually things like transactional consistency and so on that I mentioned earlier for the Lakehouse. And this is also something that we're basically working on to embrace here. Now, but one of the key things is on the right side, you see here, we are very open to connect to other engines. We are not saying this is a login thing. We are embracing these open standards, like open formats like Parquet, Iceberg, Hive Metastore standards, and so on, so that we can allow you to combine with other engines. So you can pull in other engines that do a certain job better maybe for your purposes, like Presto, or of course also Dremio. And Dremio is actually a especially good choice because it perfectly complements those things that we have not focused on with our data engine ecosystem here, especially the interactive experience and the interactive response times for queries. And that's why in the next part of the session, I'm going to hand over to Jason, who will take you through the Dremio side of things.
Yeah, thanks, Torsten. So here at Dremio, we definitely view the world in the same way. In that, really kind of similar to what Torsten talked about before, is that before you really had this, co-location and tightly coupling of, your data, your storage, as well as your kind of compute, which at that time was mainly SQL. Data warehouses and really Hadoop they had differences, but this core aspect was the same between both of them. And then really moved to cloud data warehouses, right? And that got us some really great benefits, which was great. We were able to actually decouple the storage from the compute, and we were able to scale each of those independently. And when you don't need compute, shut it down, right? And the storage was still there. So all that was great. You got compute on demand. But one of the problems was that your data was still tied to the compute. Was that basically, sure, you could load it into, any of the cloud data warehouses and you could shut it down and you could scale each independently. But if you wanted to go run a different kind of job on that data, you needed to suck it out through a JDBC connection, which at scale just is not very good. And plus you're paying the tax of that compute anyways. So really what we're seeing with the advent of the cloud lakehouse architecture is learning our lessons from the cloud data warehouse perspective of saying, hey, now we can do this stuff directly on the data, where the data is a first-class citizen, where it's based on open standards like Torsten mentioned, and that any engine can come in. And really that benefits, you as the consumer, because, when has there ever been a silver bullet for everything, right? So that does not appear to be happening anytime soon either. So, certainly around, whatever is best for your SQL workloads, maybe that's even batch versus ad hoc versus interactive, certainly around Spark if you want to do ETL or machine learning, some streaming analytics, some graph analytics, whatever it may be. all based on a single version of the data. And that means that now you're also not locked in. So if we kind of look at that from a one level down perspective, if you really have that storage layer, which remains the same, right? You have that just insanely scalable cloud object storage. It's also very cost effective. You can see there visually that you have your data, but they're all in proprietary formats, and they might even be copies of each other based on like different business units that use different data warehouses, right? Whereas Cloud Lakehouses, you have that single layer based on open standards like Parquet, ORC, Iceberg, Delta Lake, Hoodie, those kinds of things, and then you can mix and match your engines on top of them. So this is really where, as Torsten mentioned, like it's really use the best tool for the job. Generally, engines are designed to do a certain thing or a set of things well. And then sometimes people try to use it for everything, or, sometimes the vendor tells you to use it for absolutely everything, which again goes back to the silver bullet comment. So what this architecture basically allows you to do is mix and match which tool is right. So like Torsten mentioned, maybe the data engine is best for, ETL and ingestion and streaming analytics and that kind of stuff. As Torsten mentioned, it wasn't really built for interactive analytics. On the flip side, Dremio Sonar was not built for like streaming analytics. That was not the design decision that we made. We made design decisions that very much make it good for interactive SQL, as well as, really, so that's ad hoc dashboards, everything in between. So really, if you kind of look at, so this is kind of where Dremio fits, is in that interactive SQL world. If we kind of take a step, a double click on that as far as what used to happen, or like if we look in this cloud data warehouse world, what's the kind of general architecture? And with that, we generally see it. This is what the vast majority of customers have architectures. This has just been the pretty much normal architecture for the past like at least 20 years. So as you can see there on the bottom, you have you have cloud object storage, right? Whether it's IBM Cloud Object Storage, ADLS S3, whatever it may be. But then once it's into there is like a landing zone. Then generally you load it into data warehouses through like ETL, and then you're generally loading subsets, or you're doing aggregations in between, right? For either cost reasons or performance reasons, or both often. But then within there, you're actually making even more copies because people need to see things differently. You need to, again, do like aggregations of like, sales weekly, sales monthly, for instance, for different use cases. And then on top of that, though, you still need some additional performance. So you end up with, aggregation tables again, BI extracts, cubes, all of those kinds of things that, we're obviously all familiar with. Ultimately getting to your end users. And this really can, I'm sure as many of us have experienced, like that can take, often multiple days at a minimum. Weeks, or sometimes even as bad as months. Like we've run into some organizations that it takes, to like 6 weeks or more, just to go from, hey, I have this new report or this new business question. Can you answer it for me, right? Can I get the data for that? And it can take that long because this pipeline and this process just lends itself to that kind of time. But again, this wasn't like necessarily a bad decision. Like these are just things that are based on the best approach that we've had based on the tools that have been at our disposal, right? This has just been the best way. It doesn't, it has all these problems, but it still achieves, some of your business goals. It achieves enough of them where it's worth to do this than nothing, right? But if we look at it now and really, again, assessing of like, all right, now that, technology in the cloud has just led to just an explosion in technological progress and abilities, really, is there a different way that we can achieve the same thing with data on the bottom, users on the top, but without all of this spaghetti mess, right? And this brittleness and this long turnaround times. And that's really where Dremio Sonar comes in. Is it sits directly and allows you to analyze data directly on your cloud data lake storage, wherever that may be, but then really bridges the gap between that and your end users. So it enables you to get data warehouse-like capabilities and interactive performance directly on the data lake without having to load your data into a data warehouse. So it does that via, certainly we have our SQL engine, we have query acceleration technologies, which can enable you to run like sub-second dashboards regardless of the amount of scale, as well as a semantic layer that really, and as well as a UI that really makes it very easy for an end user. And in fact, technical or non-technical, we've gotten that feedback a lot, is that it just makes it very easy. And this really results in, because it's so streamlined, a new business question now comes in, and you can have that answered in hours, minutes, or days, right? Certainly not the weeks. Like we have a large manufacturing company that through the previous architecture was taking them like 6 weeks to answer a new business question for their COO. And this is like a multinational, very large company. With Dremio now, they're actually able to do that in 2 days. So it really helps and speed up that ability and gets rid of all that spaghetti and the issues with data copies around compliance. So, and again, on the note of like, this is really where Dremio Sonar fits. Like, do we do everything? Like, no, again, we aren't a silver bullet. So when you're thinking about, like, all right, when does it make sense to leverage Dremio Sonar in IBM Cloud versus some other tool? Because again, Torsten mentioned it was open. This is really where Dremio is. If you have these problems, this is generally where Dremio Sonar is a good fit for you. One certainly around semantic layer that I mentioned. This is really not having your business logic and model in 100 different BI tools, right? Because when you have extracts, that's where your business logic goes, is in those tools. Well, what happens if you need to go access that tool from a SQL client or Python or any other engine? Well, you can't access that logic, so you end up duplicating it, right? Which obviously leads to KPI drift and all sorts of problems. And one of the other big aspects is that it's really fast enough for BI, right? It provides that interactive performance that you need and that scale and that concurrency that you need without loading that into a data warehouse, right? You can do this directly on the data lake, like IBM Cloud Object Storage. We also have multi-engine architecture. So this actually allows you to run, instead of running multiple clusters or anything, you can run multiple different BUs, multiple different workloads, like ad hoc versus the COO's dashboard. Probably want to have those differently, right? So you can actually split that up, and that's all built into the product, as well as really pushing that and really integrating with that open data architecture. So we, you can do DML, so things that used to be reserved for ACID transactions, like Torsten mentioned, directly on the data lake with Apache Iceberg. You can also integrate with Delta Lake. There's also the ability to integrate with Project Nessie, which we don't have time to get into here because it's a whole topic on its own. But at a high level, what it allows you to do is benefit in the same way that Git benefited software development, as well as the resulting CI/CD and all of those kind of like the DevOps approaches. It provides that same core capability to allow you to do those same exact things with your data. So it enables that kind of microservices and that approach, as well as things like CI/CD, leveraging QA, multi-table transactions, those kinds of things as well. So again, this is really where Dremio Sonar fits. If this is compelling for your use cases, then it makes sense. If it's not if it's not, then great. Then that's really where you want to use a different engine, right? That's really where the benefits of this open data architecture, this lakehouse architecture, come into play. So with that, I will pass it back off to Torsten to kind of talk about take a step up from this guy.
Yes, thank you, Jason. Yeah, I also want to emphasize again that basically openness and lakehouse actually this is basically goes very well together. I think the whole idea of a data lakehouse implies openness, which means there is a set of common standards like data standards and metadata standards, and then you can mix and mesh those engines very freely. So that's one of the big benefits of this whole. It has already been true to some extent with data lakes and Hadoop to some extent before, but it definitely continues to be true with the data lakehouse here. And that's exactly what we are also featuring here in our own cloud, in the IBM Cloud. So I've, in the first part, walked you a little bit through the data engine part of things. And again, you can revisit the demo when we will send you the video, how that looks and feels. But one of the things that I was planning to show in the demo is actually, you can also use data engine to analyze this data, to run some queries on a real data lake that basically I'm showing you. But exactly that's where Dremio Sonar comes in, because I'm going to show you the exact same query, right? Really physically the same query and exactly the same data to run in Dremio Sonar, leveraging capabilities like reflections and so on the data, which is basically pre-computing certain aggregates and so on. And the same query comes back rapid fast within sub-second response time. And that's exactly why basically Dremio Sonar is such a great fit here. So now the question is, how do you bring those things together? So the data engine thing with the underlying, I would say, persistencies like Kafka as a transient persistency and the object storage. Those are all managed services in IBM Cloud, right? So there's the event stream service for Kafka, there's the Cloud Object Storage service, there's the data engine service, and then this slide doesn't show the code engine, analytics engine stack below data engine that you can also use. And on top, we have a set of capabilities that we call the IBM Data Fabric, which is delivered through an offering called a Cloud Pack for Data. And that basically is the thing that you can use to work with all of those data in the IBM Cloud in order to analyze it, to do reporting, to do data science, and AI and ML. So this is the higher level services. And Dremio Sonar fits in here perfectly because it gives you this interactive capability that also basically can then be used from the data fabric, which will basically, on top of that, do things like virtualization to virtualize the Dremio data from the Dremio Data Lakehouse with other repositories that you might have, data warehouses, and so on. It also adds a layer for data governance, right? How you can implement the data protection, data lineage tracking, and all of those things. Also on top of things like Dremio and Data Engine. The deployment of Dremio Sonar here is basically bring your own license, right? So I also want to emphasize that here, we are not talking about that this is something that we hosting for you as a service. You take Dremio, bring your license, and obviously you can also take the community edition, or you take the commercial license for Sonar, and it deployed into our Kubernetes capabilities, OpenShift or our Kubernetes service. And that's very easily done, as I will show you now in a second, and as I will also show you in the demo video that you will be able to consume later. So how do you get this deployed? This is basically the command line version of how you get it deployed. Just provision yourself a Kubernetes cluster from our Kubernetes service or our OpenShift service in the IBM Cloud. And then you use the Helm chart support that exists for Dremio. So Dremio deployment can be done very easily using Helm charts. And we have also prepared for you here, as you can see in this link, a repository with some Helm charts that just work out of the box with the IBM Cloud Kubernetes options. And then basically after you deploy it with Helm charts, you can go to the kube control. This is the command line version. In a demo, I'm also going to show you the Kubernetes dashboard, where you can see the deployed Dremio cluster actually running there. And from there, you will get a service endpoint. Then you can launch the Dremio UI, and there you are. So it's really something that I've exercised many times. It's a matter of minutes. Right, and to have an up and running Dremio cluster very easily without a lot of basically involved configuration. So now the question is, so now we have your Dremio cluster deployed. Nice. How do you now integrate it and combine it with the data that we have basically stored in object storage, that where we have the preparation done with Data Engine and the curation into a data model and so on. All of that has been done with Data Engine. So here the thing is, the important thing to understand is IBM Cloud Object Storage is just S3 compatible 100%. So that's why all what you do in order to connect to the object storage is exactly what you see on the slide. You just say, I'm connecting to an S3 data lake. With the only little caveat, there's basically an advanced parameter they need to set to override the endpoint. So there's a different endpoint, obviously, because it's running on the IBM Cloud. The rest of that is pretty similar. So you have access key, secret key to access it. And from that point on, it just looks like any S3 data lake to you. And again, I'm referencing here to the demo where I'm going to show a little bit now how that looks and feels. So that's what I've prepared. We will put it all into the video. So I want to end basically today with one more option, because when you do that, right, you put Dremio side by side to data engine, and you work on the same data and metadata, which is actually, I think, the recommended way to do basically your thing, because this is where they really complement each other perfectly. You can, however, for certain use cases, also stack these engines. So there's a thing available here, a connector for Dremio to the IBM Cloud Data Engine. This is something where you need to install basically the connector to your Dremio image from Dremio Hub. So this is a Dremio community with Dremio extensions. There's a connector available for Data Engine. And the difference here is that in this case, Dremio acts as a federation layer. Right? Dremio has many connectors to many other, as you can see it on the left side here, repositories, databases, and it can federate queries across those, and it will push down SQLs. So this is an option that is also available, which is however not the option that basically I want to emphasize today. I just wanted to, for completeness, point that out here, because what I emphasize today is you share the same data and metadata, and you have the one side of engines which we provide organically in IBM Cloud for data ingestion, preparation, basically onboarding of the data to a lakehouse, and then you come in with Dremio Sonar, and you basically drive it home by basically doing the semantic curation and consumption of this data in a very interactive fashion. So that has been the content for today. I'm sorry again that we couldn't basically do the interactive demo part here, but for a lot of things, like I was pointing out, we will have some interactive to show you. I think we'll do this within a day. I think by end of the business day tomorrow, we should have this video available for you in the downloads resources here of this presentation. So I don't see any open questions right now. I think a couple of one have been answered while we were speaking already. So with that, I think we can close the session for today. So thank you very much for your attention. And I'm looking forward very much, and I think I'm also speaking for Jason, to hear from you. And we will be more than open to follow up with any conversations here for your architecture, your solutions. Don't be shy of contacting us. Thank you very much.
Absolutely. Thanks, everybody.